string like A, okay? Yeah? How many? If we want to split, split the string into two non-empty parts. Split into two non-empty. How many ways can we do it? If we can split the string into two parts, but both needs to be non-empty. How many ways are there? If the string has these 5 characters, how many ways can we split the string into two non-empty parts?
2.
2, yeah? 2? 3 or 2?
2.
What?
4.
Okay, can you list the
A and abba, and bab.
okay, and then?
And ab,
Okay.
and abba, and b.
Okay, that's it. Yeah? Non-empty part. Okay, so then look. Yeah?
Yeah.
Okay, that's funny. How many characters? 1, 2, 3, 4, 5. That's n. And how many ways can we split it? 4. So it's n minus 1, yeah? Because we want the non-empty part, okay?
Yeah.
Okay. Okay, so apart from these 4, there are 4, yeah? Which 2, if we split it to 2 and each part has the same number of distinct characters. Same distinct characters.
What does that mean?
Distinct. Distinct, what's distinct? Unique, yeah? Characters.
Unique.
So look, here we only have A, here we have AB, right? So look, here has A, this has AB. It's not the same. Here AA, here AB, here A, here AB. Not the same. Here AB, here AB. Look, here has 2A, 1B. This is 1A, 1B, but both have letters A and B. So here we count it. And here, no, right? Yeah, this is A and B. Here is B, doesn't have A. Okay, so we want to check.
So the ab
Yeah.
and ab is correct.
Okay, so look, what's the purpose here is we want to count how many ways we can split into
There's only one.
two partition, yeah? And both parts have the same distinct characters, right? Same distinct characters. Any idea how we can do it? Any idea how look?
Okay, so we just sort.
How many ways we can split into? Look, we said n minus 1, right? So we can brute force it, right? We can just brute force each, right?
And then
How do we check if both have
put it in the set.
in a set, and what particularly in set would be the good idea. And another way we see what kind of data structure are we using to count? Counter, yeah. We can use the counter and we check the keys, right? We check the length of the keys if it's equal, right? Yeah? Okay, so let's quickly write this, okay? And then you know what. By implementing this, we know the problem better, okay? Please define, okay? Let's say just split into 2, split 2, okay? S. So first of all, if the string is empty, we just return 0, yeah? Because there's no way to split into 2, okay? Now let's implement it. Let's do this. For I in range length S, okay? And then look here, S is here. Now I just need to iterate. This is I is 0, so I need to look here. This part is S I plus 1, okay? And then the rightmost bit, we split into the string into 2 parts. Yeah, the left bit is this, yeah, up to I, including I, right? The right bit is start from I plus 1 to the end, right? Okay, so let's say C1 equals counter. Yeah, we want to count S up to I plus 1, and C2 is we want to count the string on the right, right? So it's counter S I plus 1 to the end, right? So how do we check if both parts have the same number of characters? Distinct characters.
Is,
We check the what? What do we check? What's counter? What does the counter have?
Yes, you count them.
So what's the key of the counter?
It's like how many times each one appears.
That's right, yeah. So the keys are the distinct characters. The values are the number they appear, right? So we want to check the keys or the values of the C1 and C2. So how do we compare if it's C1 or C2? If what?
If the one is 1.
C1, what's how many characters in C1? How do we use it?
Is the same as the.
Yeah. So it's length, the key, yeah? The length C1, this is the number of keys, which is the number of characters, equals the length of C2. Alright? And then we implement answer equals 1. Now we need to initialize the answer equals 0 and return answer. Right? Yeah? Yeah? Make sense? Look, we go through the I, and then each I we split into 2 halves, and then we use the counter. Right? The counter we count the string on the left and the string on the right, the partition, yeah, 2 partition. And then if the keys, this is the key, the same number of the distinct characters. Yeah, we don't compare with the values because values could be different, right? Yeah, AAB and ABA. Yeah, that AAB, which is what? A2, B1, right? And ABB, which will be A1, B2, right? Look, but then C1 and C2 both return 2, so these two equal, right? Answer equal 1, plus equal 1, right? Make sense? Yeah? We don't compare with the values. We only compare with the key, the length C1 and C2.
So does that mean you only contain A's and B's? Because you said we return 2.
Okay, yeah, that's very good point. Okay, so let me rephrase this bit a little bit. If the string only contains 2, A and B, okay, and how about if we don't contain it? If not, then we can change this to what? If we want to compare, the A and B are also equal, right? Yeah, yeah. So then we can set what? If set C1 dot keys. Okay, so if C1 dot keys, yeah, C1 dot keys is the A and B, right? And equal set C2 dot B, yeah? Yeah? Okay, and then answer plus equal. Okay? Make sense? Yeah?
Yeah.
Okay, that's a very good point. Because if we use the length, what could happen? If A and B, and this could be C and D, they're different, right? But they're also 2. Make sense? Okay, that's a very, very good one. Okay, what's the time complexity? This is quite tricky. Look, here is n. We're done, n squared. Because counter, we have to do this, and there's n here. And then that's here, n, so n squared. Space complexity. What's the space complexity?
Counter.
On, yeah, because we use the counter. Okay. We can do it. We can do it faster. Yeah, we can do it faster. Why is that? Look, every time.
By just writing the answer with your big brain.
Okay. So now look, I'm telling. Look here. This is C1 and this is C2. If I move the partition 1 character to the right, what happened? If I move this I partition 1 partition to the right, what happened? If this character is SI. How do we update C1 and C2? Yeah? Currently I'm here, the left is C1, the right is C2.
Yeah.
Okay, so what happens if I move the I 1 position, 1 character to the right? So what do I need to do with the CI?
+1.
CI needs to include this letter, yeah? But C2 needs to delete it. We're done, right? So this one is slow. Why is that? Because every time I need to count it again, yeah? I need to dynamically counting the 2 parts. This takes a long time. But look, I know every time I move 1 character, I can update it 1 time. I can update C2 1 time. Okay, right? Yeah? So that will be a faster, right? At least it will be faster, okay? So let's do this.
You're not going to raise the whole thing.
Just half of it.
That's about.
Okay, so now I need to declare the C1 and C2 outside. Yeah? C1 is on the left counter. So it will be empty. So what happened to the C2? C2 will be counted, but instead of look at the beginning, C1 is nothing here. Yeah, nothing here. C2 is the whole string. So what parameter should I give it to?
String S.
S, yes, S here. S, yeah. This is C2 here. C2 here. Okay? And then I just need to go for I in range. By the way, we don't need to, in the previous one, we don't need to go through the N. We need to go through till N minus 1, right? Because they are non-empty. So in range here, length S, right? We can minus 1, right? Because there's no point of checking, yeah? There's no point of checking till the entire part because if both is non-empty, okay? So we can minus 1 here, right? Yeah? Now, look, C1 and C2, okay? Now, C1 needs to include a letter at here. So C1, SI, Ryan, please don't sing, okay? Plus equal 1, okay? Now, C2 needs to remove it, yeah? Yeah? C2, SI, minus equal 1, okay? Yeah? But when we minus equal 1, it might reduce to 0, right? When it reduces to 0, we need to get rid of it, right? Look, if a counter is A equals 1, right? If after this, if C2 is this one, C2, A minus 1 will be equal to 0, right? Yeah? So we need to remove this bit again. So we just say C2 SI equal 0. Then we delete. Okay, delete. Yeah, DL stands for delete. Delete C2 SI. Right? Yeah? Yeah, and then we check if C1 equal C2. Yeah, actually is we need to compare the keys. This is the same, yeah. We need to compare the keys only, yeah. C1 dot keys, yeah. We want to compare to the keys. The value doesn't matter. Equals. I will put it in the set, yeah. Set doesn't compare with the order. If the set C1 and equals set C2 keys, if it's equal, then we do the answer plus equal 1, right? And then return answer. Make sense? Here, answer equals 0. Okay? Yeah? And here, look. I is the partitioner index. And the partitioner index moving from left to the right. And every time, I need to include the SI character to C1 counter. But I have to remove it from C2, right? Yeah?
Yeah.
And after it remove the C2 completely. Look, if it is 2, that's fine. I remove 1. But when this reaches 0, I need to get rid of this. Right? Because if not, set C1 dot keys, A will be still included here. Right? We don't want to include the keys with the appearance 0. Because when it reaches 0, it means that there is no such character in the set. In the current window. Okay? So there are 2 windows, yeah? Left and right, C1, C2. And if the set, if it's equal, then we answer plus equal 1.
Answer plus equals 1.
Okay? What's the term complexity at this point? Oh, what?
N. Plus.
This is N, yeah? O-N.
O-N.
Okay. O-N, yeah?
Square.
These, almost, yeah? Because we're converting the set, okay? Converting to a set. So this is, in the worst case, C1 dot keys could be N. I'm converting to a set. And then C2 dot keys. Okay, so maybe we can just check the values first. We can check if then C1 dot keys equals then dot C2 dot keys. Right? Yeah? If the characters number is not equal, then there's no point to check the content of it, right? Yeah? Okay, so this is a lot faster than the previous one, right? Because look, these 2 operations, O1, right? Counter is basically like a hash table. When we updating the values, yeah, and all delete the values from the hash table is O1 constant. It's constant term, right? Previous one we are creating. We need to count it, Right? That takes on time. So this is faster here. Make sense? Okay. Any questions so far? Okay. And no questions? Okay, so what have you learned today? What's this approach about?
String shot.
Can you tell me everyone what?
Is when like you split.
So how do we I mean what's the approach here? What's the approach here today? Can you explain to people? Yeah.
Is about so you got two you know the window thing
Yeah.
and you
And what? The number of distinct characters in each string is the same. Okay. So it's here is looking for the number of distinct characters. So it doesn't compare the content. Okay. Okay. So the question. Okay. So here. We are now comparing each one has to be appear in the same, so we can actually change it to length. We just compare with the length, okay? Then it'll be easier, okay? Okay? Yeah? The number of distinct characters. So it could be in each window, here will be A, B, here will be C, D. It doesn't matter, okay? Yeah? I see, okay?
okay.
Okay, so look at here, then if we change it here to length, then this is obviously ON, right? Because checking the length is constant time, okay? Checking the length of constant time. Okay, so what have you learned so far? What's this bit, Eric?
You have to have the same amount of number distinct.
Yeah, and how are we doing this? How do we use this?
We just like move
We slide in window, yeah? We move this positional point and update what?
set.
Update each C1 and C2, okay? Yeah? Because we move one character to the right, and what should we do with the C1? What should we do with the C2?
One increase it gets the thing and one deletes it.
Well done. Okay, that's it for today. Good job. Bye bye.